Welcome back to part 3 of the Road to Digital Automation at Toyota, Learning How to Be an Informed Customer. Part 3 is Modeling Sequential Decision Problems. Now, I need to make the point that we're going to talk about a general modeling framework. This is not aimed at people who are actually going to do mathematical modeling, but more to make the point that if you follow my guidance for framing the problem, that you could model it if necessary, which means there's a path to putting this on the computer. Okay, so let's start. The biggest challenge when making decisions under uncertainty is modeling. Uh, Everyone writing out a deterministic optimization model or a machine learning model knows how to write their problem mathematically. Everybody who learns that material learns that in a course. But when we get to sequential decision problems, we lack a general framework. I like to refer to this as the jungle of stochastic optimization. Every single one of these terms refers to a community. There's a book, sometimes a whole series of books, 8 different notational systems, a variety of different methods, all different types of applications. These are communities that sometimes know of each other. Often they're just completely separate. Let's take a look at our inventory shelf. Now, the books on the left, these are the heavy theory books. This is basically playgrounds for PhD students who are looking for some math applications. In the middle, these are books primarily used for MBAs using what I call watered-down mathematics and simplified models. Now, the books on the right, these books have no math, but they use analytical thinking. Now, none of these books shows how to properly model a real inventory problem, not one. So it's amazing that all of the books used to teach MBAs and industrial engineers, nobody is actually learning how to model a real-world inventory problem. And the difficulty is that there's a widespread problem with how to model problems that involve decisions and uncertainty. This is not a problem unique to the inventory and supply chain literature. If you go to my jungle, these books just don't set up the foundation of how to do modeling of decisions and uncertainty in a general way. And then so the people who need to use these techniques on a problem like inventory planning have to sort of make it up on the fly. So I'm going to show you a general purpose modeling framework. It all fits on one PowerPoint slide. Okay, so just bear with me. I'm just going to walk you through this because it's very simple. We start with a state variable. A state variable in plain English is what we know. It's what we know or believe. We may have estimates, okay? But this is all the information. So when you sit down to your laptop or computer screen to solve a problem and make a decision, all the data you're looking at falls in this variable st. Then you make a decision. That's what we call xt. So here we wave our hands and say, okay, anytime you make a decision, I'm going to represent it by xt. Now, wt plus 1, that's that information that I showed you earlier that arrives after you make a decision, okay? Now, each time we make a decision, we get some performance metric that can depend on information in ST plus your decision. Okay? And by the way, this can be more than one metric. Now, decisions are made with a method. We're going to call it a policy. We'll get back to that later. And I'm going to use this funny notation xpi. The Greek letter pi stands for policy, and pi carries the information about what type of function it is. But the key thing is that we will design this later. This is the point of departure with my way of approaching these problems and all of those other books. Okay? We're just going to say, look, I have some function, I'll get to it later. Now, state variables evolve using something called a transition function. So this says, let's take what we know, let's take what decision we made, and I don't care how we made it, then let's take the new information that I didn't know that came from outside the system, and now here's the updated state variable. And I may have equations to do with this in the computer. Sometimes I actually have a real-world problem where I don't know how it evolves. I just observe it. Now, down at the bottom, the goal is to find a policy, pi or xpi, that optimizes performance over time. So I want to find the best decision rule that gives me the best performance over time. Now, okay, I said one PowerPoint slide. All I'm doing here is there's nothing new here. I just put it in a list with 5 elements to say this is our sequential decision version of that math program that I showed in one of the earlier talks. So there's 5 different elements: our state variable, decision, and information. Then there's the transition function that shows how we evolve over time, and then the objective function that says here's how well we do. With this framework, I can model any sequential decision problem. I can model all those applications in the slides and anything else. I can also model all of those problems in those books. So even though they have all different notational systems, I can cover all of them, sometimes in a more general way, using this notation. Now, so let's compare level 5 uh, vocabulary to level 6. So level 5, we saw this min cx subject to ax equals b. So this is the language of deterministic optimization. This is the language of making a decision at a point in time. Very mature. We have a whole library of solvers to solve this. Uh, Level 6, what I'm going to do is I'm going to use this little box to represent the universal modeling framework. You know, instead of calling it Bob, I could have called it Bill, but whatever. I'm just going to use this box. Let's no longer worry about that notation, just to say, as long as I'm filling in what do I know, the information, what decisions do I make, and then what do I observe after I make the decision, I can model it. Okay? Now, the key thing here is I can take any problem, turn it into that framework, and once I have in that framework, I can put it on the computer, because this goes directly to computer software. So this answers our question of, if I put in this format, can the computer help me solve it? By the way, if you put it on the computer and you've done things correctly, I can always translate what's in the computer back to this notation. Now, I have a few books. Here's my big book. This is a graduate level book. This is for people actually writing code, all right? And I'm putting it out here just to say it's out there. This isn't just hand-waving nonsense. It's an 1,100-page book. It has mathematics at the level needed by a programmer. This is not for theorem provers. When I taught this at the graduate level at Princeton, I had 50 students from 10 different departments, including politics and economics and physics, plus all the engineering departments. Now, I have another book, Sequential Decision Analytics and Modeling. I wrote this for an undergraduate course. Now, it still has mathematical modeling, but it uses a teach by example style. Every chapter, other than chapters 1 and 7, is a different example, all modeled using the universal modeling framework, okay? And you can download this for free. So far, I have 16,000 downloads. It's getting a lot of attention, and it's very easy. I really recommend that anybody who is interested in the math modeling absolutely look at this before you look at the big book. But again, the big book is for the people who are doing code, or by the way, who want to show off on their shelf, because it's quite a big book. Now, the book I'm very excited about now is the one that I'm writing right now. I'm calling it Decisions, Framing the Problem for Better Models. Now, this is a book that's sitting at that step in between the very real business problem and the universal modeling framework. What we're going to do here is, so after starting with an introduction, overview, and a series of applications, I'm going to have 3 chapters covering metrics, decisions, and uncertainty, drawing and illustrated using the applications. And these first 5 chapters have no math. Okay, very important that this is that stepping stone between the real problem and the universal framework. Now, chapters 6 through 12 will step through all of the elements using, in a very light way, the universal modeling framework. And then we have some more advanced chapters, including chapter 16, navigating complex environments. And that one's new. We'll have to see how that unfolds. So let's go back to my skill cycle. So in the upper right-hand corner, that's my framing step. And I think we need to develop that skill set. I would love to see business schools taking people that, instead of learning watered down math, I'd like to tell them not to learn any math. Learn how to do the project framing. Learn how to ask the right questions. I have seen no shortage of mathematical models that are just wrong because they phrase the problem wrong. I have created many models on my own that were wrong because nobody knew to tell me what the answers to these 3 questions. Now, answering these questions is not trivial. It requires some training. It requires people who know something about the business setting. If you're doing this in the context of supply chain management, it helps to have somebody knowledgeable about the field. But of course, supply chain management is an umbrella for a wide range of problems in business and logistics. So you can't just know inventory theory here. And uncertainty gets quite rich. But again, 3, 4, and 5, no math, no coding. You have to know how to ask the right questions. And when you can get the answer to these questions and you sit down with a modeler, the modeler would go, holy smokes, what a clear statement of the problem. Now, it is going to be sometimes true that you don't need a modeler. You don't need a software or any math. Just answering the question this way can help you think about a problem more clearly. And sometimes it'll help you solve it even without any technical work. So it lays the foundation if you do need a computer to help you out, which might just be a spreadsheet. But sometimes once you have it clear, now not all problems can go on the computer, and I just think it helps you think about the problem more clearly. Okay, once again, there's additional information at this web page. I will emphasize that this is a little bit more technical material.